undoubtedly recall from our first 6 weeks together, um, I lean towards the JUnit 5 and using Gradle. And so the materials that we got are oriented towards JUnit 4, of course, and using just plain IntelliJ projects. And so we will be setting up that project from the material. We'll also be doing a little bit separate from that. And we will be using, of course, Git to put things under version control. We want to make that part of our daily practices. I would imagine that's probably been part of your daily practices for the JavaScript part of this. I don't know about whether it was emphasized that much in the Python part. But anyway, that's what we're going to be doing today. We're going to be looking at a couple of interesting algorithms, mostly to kind of refresh our understanding of what an algorithm is, and to give us a way to talk about computational complexity. So given that, what I'd like to do is do a really quick kind of a red light, green light, yellow light scrum. So if you would turn your cameras on, please, and let's do a quick scrum. And the question this morning is really whether you did a quick review of Java yesterday, and you've been living in the land of other languages for the last few weeks, and that's the life of a developer as we go back and forth between languages. There's realistically no way to make a career as a developer using a single language, even a single primary general purpose language. We've talked about special purpose languages like SQL, which is a pretty broad special purpose language, but still a special purpose language. And we've talked about special purpose languages like the language of regular expressions, things like that. But leaving those types of languages aside, there's really no realistic way as a developer to make a career around a single language, a single general purpose language. So spending 6 weeks on Java, then 4 weeks on JavaScript, then a week or so, however it was, on Python, and now we're back to Java. That's not atypical. So sometimes it'll be much longer than that. You'll do a project in language A. You'll get really good at it. You'll feel like, yeah, I got this down. And then the next project is, oh yeah, but this one, you know some Python, right? Do this in Python. Or you know some Java, right? Do this in Java. So kind of get used to this. So really what I'd like to hear now is red light, yellow light, green light on how prepared you feel, how ready you feel to spend this, to kind of go full speed today using Java, using Git, and using Gradle. So let me begin. I'll begin at the end of the alphabet today. Let me begin with Wale. Good morning, Wale.
Good morning, Nick. Yeah, I mean it was nice going through the reviews yesterday and stumbling on some of those stuffs all over again, and refreshing the mind. I can't wait to do a deep dive into dataset and algorithm today. So looking forward to that.
Okay, good deal. Shinar, how about you? Good morning.
Good morning. I would say green light. It was very good to have like review and knowledge refresh yesterday. So I'm looking forward to learn about algorithms today.
Okay, fantastic. Shaq, good morning. How about you?
Sorry, I actually missed the question you asked.
Oh, it was just red light, yellow light, green light. How ready you feel today to kind of move full speed ahead with back to Java, and we're going to use Git, of course, and Gradle today.
Green light, sir. I'm ready.
Fantastic. Glad to hear it. Sam, how about you?
Good morning, everyone. Yep, green light yesterday. What a good refresher, and also I think like some of the thing towards the end was something new, like we haven't used in our Java class, especially building the function and calling it with the lambda expression. And yeah, that was new. And yeah, green light. Uh, I think Python kind of spoiled me, and I try to write a little bit of code. I keep on missing the semicolon and like data types all the time.
Yeah, yeah. So a quick, I'm glad you felt that way yesterday. A quick thing. So one of the things that I think Nadra was trying to do at the end of the day yesterday was to show you that we can do our own functional interfaces. And lambdas are always, always, always implementations of functional interfaces. So we did work with lambdas at the end of the 6 weeks, but we were generally doing that based on functional interfaces in the standard library. But there's nothing at all that prevents us from writing our own functional interfaces. Nothing at all. And if we have a functional interface, we can write a lambda. There's the interface that defines or that declares the method that we have to implement. But then the lambda itself is the implementation of that functional interface. And we actually won't do a whole lot with that over the next few days. Some, but we won't. Hopefully, when I think in sorting tomorrow, when you talk about sorting, there will probably be a little bit of opportunity to use a lambda for comparators. And that was one of the main things we looked at as well in the 6 weeks when we talked about lambda was comparators. But the fun part is that we can write our own functional interfaces, and we do it all the time. All right, Robert, how about you? Looks like Robert's microphone isn't hooked up. Is Robert on camera? He might not be at his desk at the moment. We'll come back to him. Nina, good morning. How about you?
Good morning. I don't know about going full speed ahead, but I would say that I'm at like a yellow light going over everything yesterday. I feel like it was like, okay, I remember this, and I kind of was like comfortable with it, but there are still like places where I feel like there are some gaps still. So I'm
Okay.
comfortable for today, but I'm still proceeding with caution, so I'll say a yellow light.
Okay, that's fine. And of course, you're going to be living in Java land for the next 5 weeks. You've got this week, and then your practical applications will be primarily in Java, your practical application. All right, Nitin, how about you? Good morning.
Hi, good morning, sir. Good to see you. So I'd say green light for me. It's like I'm going back to like a familiar place. So yeah, I was like, oh, this is here, that's there. Okay, there's cafe right there or whatever. Yeah. So yeah, getting used to it, but like I'm confident. But yeah, maybe yeah, if you go too fast, I'll let you know. Thank you.
Okay, thanks. And in fact, it is quite easy, if your background is more in Java, it is quite easy to get spoiled by Python and to feel like, oh man, I love this. This is pretty. I can write things very quickly. I can get stuff running very quickly. Um, and that's how I feel a lot of the time. And if I have to do something where I have to get something up and running quickly, especially if it's kind of like a one-off, I'm going to turn to Python almost every time. But if I have to write code that I'm going to maintain or that I expect someone else to maintain, um, I'm generally going to go with Java or Kotlin. All right. Let's go to Kyle. Good morning. How are you?
Good. I'm a green light. I feel pretty
Okay.
good going into it. So
Great. I'm glad to hear it. Kita, how about you?
Hey, good morning, Nick. Good morning, everyone. I think I am a yellowish green. Um, I was like actually starting to kind of understand some of the patterns I was seeing last night when I was looking at like the big O notation videos and whatnot. And it was a really good review on Java. I felt like I understood it a little bit better the second time around than the first time around. So,
Good deal. Good deal. Yeah, I actually like those videos. I think the videos were pretty good. Um, the instructor who wrote the material that you'll be working with this week did a nice job of curating a bunch of stuff. So I think the videos were great. Bless you, Robert. And I will go back because we skipped over you for a moment, Robert. So let's go ahead back to you. So the question is red light, yellow light, green light on kind of
Oh,
how ready
well,
you are
yeah,
to
definitely.
jump
I
back
would say.
into Java and Git and Gradle.
Oh wait. Oh, is it me?
There you are. Yep.
Oh wait. Oh, sorry about that. Yeah. I would say Green Light. It was definitely a good review. I forgot a couple things on like functional interface and stuff like that, but I recognize it. And then
Good.
anyways, I look forward towards learning more about data structure and algorithm. So yeah.
Fantastic. Fantastic. Okay, Ken. Good morning. How about you?
Hey, good morning, Nick. Welcome back. Honestly, green light for everything. I haven't had any issues yet. The Git, we've had a lot of practice, like you said, with JavaScript and Python, so it's gonna be really, I think, fluent as we get started here. Lambdas, the same thing. Only difference, obviously, with Lambdas is we didn't have to make these single classes with one function to instantiate a Lambda, but now we're kind of getting back into that, so there's going to be some
Yeah.
practice.
Yeah.
It's
Yeah.
a
That
funny
is
thing
the
yesterday. I was trying to just practice some class coding, and the whole file was red, and I couldn't figure it out. And I'm looking at it, I'm like, what the heck is wrong? And I realized that the new keyword to instantiate my objects was missing literally through the whole file.
Yep. 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 Yeah, that's definitely one of the things that happens to us coming from Python back to Java. And I don't recall if I brought up this term when we were together for 6 weeks before. Um, but in Python and to a certain extent, well, actually to a great extent in JavaScript, we have there's something we call duck typing, and duck typing is kind of what it sounds like. If it walks like a duck, talks like a duck, it's a duck. And and that's kind of how lambdas work in Python and JavaScript as well. JavaScript anonymous functions, the JavaScript arrow functions, the lambdas there as well. Is that if you pass a lambda to something like the sort method, for example, if you pass a lambda and it looks like it's got the right parameters, it doesn't care whether there's a functional interface there or not. Um, and in general, yeah, we don't have to worry about that kind of stuff in Python and JavaScript. Even in something like Kotlin, we have a lot more flexibility around lambdas. So lambdas in Java are definitely something that was okay. How do we maintain backward compatibility? How do we not break any existing code, but bring in this idea of a closure, an anonymous function, a lambda, into this language? And so there are some very strict rules around lambdas in Java, just like there are strict rules around lots of other things. Um, but sometimes those strict rules are very useful for us. And some languages that have emerged out of the kind of the genealogy of languages, really a lot of their value has been to encourage certain rigorous practices. And Java kind of falls into that category. The Pascal branch of languages falls into that category of encouraging rigorous practices. So, all right, Katie, good morning. How about you?
Can you hear me?
Yeah.
Okay. I would say green light. I'm feeling pretty good after yesterday. I think, um, I think with interfaces and generics and abstracts, that's something that I want to have more practice at, but I think it's just necessitating the build, right? So like, when can I use an abstract class in my own personal
Of
projects?
course.
So kind of just asking
Of
myself
course.
those questions, but stoked
Of
to get
course.
started.
Great. Understand. Definitely understand. And also, one of the things that you've already dealt with in going from different languages is the different terminology in the different languages. But you're also going to see this week and then the next 4 weeks differences in even how practitioners of one language refer to things. So there will be some things that you'll hear Nadra and your instructor starting next week talk about where they refer to things one way. Nadra referred to an interface as an interface class. And some Java developers will say things in different ways. So there's multiple language, how best to say it, multiple language translation where we have to recognize that, okay, this in this language means this. When can I use this? Really, how does that map to this other languages? But then there's also the fact that different practitioners will talk about things in different ways that we have to deal with. All right. I don't think this week we'll deal much with abstract classes, but hopefully some lambdas. Jay, how about you?
Hey, good morning, everyone. I think I'm a faint green. Yesterday was refreshing to go over some past stuff that we
Okay.
learned, and I definitely like some more practice with some lambdas. Yeah.
All right.
So yeah, faint green.
Okay, very good. Very good. Well, we may end up today, depending on the amount of time, we might get a little bit of time to practice some Lambda stuff today. Today, just so everybody knows, we're going to focus on algorithms for going between different number bases, between representations in one number base. And I've got some reading material for you at the end of the day that's not part of your homework, but can give you a little more foundation in that, stuff we didn't get time for in the first 6 weeks. But we will get practice. James, good morning. How about you?
Good morning. Feeling pretty good. Green light.
Great. Fantastic. Jack, good morning. How about you?
Hi, Nick. Hi, Nick. Good morning. Yeah, I feel green and excited to touch algorithms again. So, yeah, excited
Okay,
about this
very
week.
good. Very good. And just a little callback to a few weeks back, there was a document that we looked at about week 2 on algorithms pseudocode. That's still available. That's still in your Java 1 files area in additional reading, and you may find that useful this week. You may not, but remember that that's still there. All right, Henry. Good morning. How about you?
Morning. I'm pretty much green light to follow along, and if I need to do something on my own, it's definitely a yellow light.
Okay. Okay. Eric, good morning. How about you?
Hey, good morning. Yeah, I'd almost kind of mimic Henry's response, where when anyone's talking about it, I'm following along. It's like I'm tracking it, makes sense, and then put on my own, then it's a little bit like, oh wait, I don't even no idea what I'm doing. So it's like the first time I've seen this code, So, so
All
yeah,
right.
it's right between green and yellow. I think conceptually,
Okay.
I feel like it's a
Okay.
green, but when I have to do it on my own, it's more of yellow.
And just so everybody knows, for my part, and I'm sure for Nadra's part for the rest of the week, I certainly have no expectation that you remember everything from the first 6 weeks at all. My hope is that the things that we did every day, just the basic mechanical things that we did every day, naming conventions, a little bit of stuff in IntelliJ itself, and a little bit of things with Git. My hope is that stuff's pretty solid. But things like, I just saw this come up in chat, things like composition versus inheritance, is of versus has of versus using, kind of 3 different relationships there that we frequently deal with. I those kind of things, if those take time to kind of refresh and bring back, that's to be expected. That's to be expected. Now, I think I'm more prone to say, Henry, hands off the mouse than anything else. All right, Ebenezer, good morning. How about you?
Good morning. So with Git, I feel like it's green light. With Java, the review yesterday was really great. I still don't feel 100% green light with that. I feel it's more yellow light. So overall, I would say it's yellowish green, and I'm looking forward to the algorithms and their structures here.
Okay, fantastic, fantastic. David, good morning. How about you?
Good morning, Nick. Good morning, everybody. So I'm going to jump on the train with the soft green. I felt we started talking about yesterday, and it felt like I had a brief moment. I was like, "Oh my god!" Like I brain dumped everything. I can't remember what is Java. But it wasn't too long. Nadra did an excellent job on that review, and it wasn't too long before a lot of the things came flooding back. And obviously seeing it the second time around after having some time away from it, there's a couple things I was like, "Oh, that makes more sense the second time than it did the first." So, however, I do feel like I've got a little bit of the imposter syndrome setting in, and I feel like right now, like my confidence isn't as high as what my ability probably actually is. So flirting on a soft screen, we'll kind of see how it goes.
Okay, and I think you're not alone in that. I think we all go through that in learning. We go through the imposter syndrome. We go to that when we first go into the wild and are working at our jobs, and it comes back from time to time, less and less, but it comes back from time to time. And you're right. It's kind of it's an illusory self-assessment about our own capacity. That generally our capacity is greater than what we think in that case. Of course, there are times when we think we can do more than we can. Mostly that's a matter of capacity in terms of like bandwidth than capacity in terms of competence. And capacity is really both of those. It's, are you capable of doing this? Like, do you have the skills? Do you have the competence? And the other half of capacity is, do you have the bandwidth? And one of the biggest risks that you're going to have, that all of you are going to have as you go and do your OJT and then get more and more independent work assigned to you. One of the biggest things, one of the biggest dangers you're going to have to watch out for is overcommitting, is you feel you're it's a kind of an archaic phrase. You're feeling your oats. You feel like, aha, I can do this. Aha, I'm master of the universe. And as developers, we are masters of the universes that we create in code. But then we end up committing to do too many things and to do too much, and we end up failing, and it feels like hell. Not because we don't know how to do things, but because we simply have bitten off more than we can chew in a particular moment. So that's that's the flip side of imposter syndrome, is I am a god. And then we commit to do too much work. So you got to watch out for both sides of that. Daniel, good morning. How about you?
Good morning, Nick and class. Just forewarning, my internet's like being very spotty this morning. I think they're working on antenna, so I might be popping in and out.
Okay.
But I want to say overall, I'm green. I wish I could have spent a little bit more time on Python, but that's something I had to do on my own. Because my team told me that we use a lot of Python. But in terms of Java, the review was solid yesterday. I think I'm definitely looking forward to seeing how it's being put into algorithms and data structures. One thing that I do look forward to seeing is, as we're doing these algorithms, the implementation of the Java stream as well. I've heard from a lot of associates within Amazon that they love streams. So I think
Streams
overall,
are great.
yes, I've been doing a little bit of side research on it too, but for sure, in the context of algorithms, I think it'll be very fun way to learn it. And so yeah, overall green or soft green, I guess, definitely.
Okay.
Looking
All
forward to
right.
learning.
Great. Yeah. Unfortunately, in our first 6 weeks, that's my first cohort. So I was trying to figure out, okay, how do the things that I want to do work in with the material that's already written? So we didn't get as much time to spend on streams as I would like. I figured it out a little better for the next cohort, but too late for you guys. But yeah, I hope. I'm not sure how much you'll get to streams this week. We won't get to any today, but streams are great in your practical application. Streams are just these fantastic facilities in Java that really leapfrogs over some of the things that we do in Python. For example, in Python, we have what we call comprehensions, where we can construct a list with a comprehension. We can construct a dictionary or a set with a comprehension. We can manipulate. We can take one list and transform it into another using comprehensions, or one dictionary, or one set. And that's about as close in Python as we get to Java's streams. And Java's streams kind of take that and they go crazy with it. They go far beyond that capability. And Java streams really are a very powerful framework. Very powerful. All right, Blair, good morning. How are you?
I'm good, Nick. Thank you, and welcome back. Good
Thanks.
morning, everyone. I would say overall, I'm a green light. Took kind of a second to grease the wheels for getting back into Java, but feeling pretty good now. So I definitely say green light. Thank you.
Okay, great. Glad to hear it. And Augustine.
I would say green light. Everything that we did yesterday, I was like, oh yeah, I remember that. Like, oh yeah, I remember that. And it was the entire day, I was like, oh yeah, that's how you do it. But
Good deal.
overall,
Good
pretty
deal.
green light.
Yeah, good deal. This kind of program is intensive. It's like 18 weeks of cramming, especially what you've done up to this point. So the first 13 weeks, you've essentially been cramming information in there as fast as you can. And what that means is, as new stuff comes in, the old stuff like kind of fades pretty quickly. So I think that's part of the reason that Amazon, when they spec'd out this program and worked it out with TLG, they said, let's start and end with Java so that you're coming back in, reinforcing a lot of concepts with Java. All right. Fantastic. Thank you all. Let's go ahead and turn our cameras off. And we will be doing some work in breakout rooms today. Oh, that's not what I wanted to do. We will be doing some work in breakout rooms today. And but first, I want to make sure we're kind of set and ready to go. So please give me, if you didn't do this last night, it's okay, or last weekend, whenever, give me a thumbs up if you already downloaded the workspace directory from Teams and set it up in IntelliJ. If you got most of that done, give me a thumbs up. If you only got part way through and then said, I can't remember how to do this, that's okay, don't worry about it. But I'm just curious how many of you did that setup. All right, good to know, Shaq. So let's very quickly go through that for those of you who did not do that, which is okay. It wasn't assigned as part of the homework. So let me clear all the statuses. So in Teams, let me share my screen up here, and there's data structures, and there's my button to share. Second monitor share.
Hey Nick, can you start the recording, please?
Oh, thank you very much. Thank you very much. All right. So in Teams, in this 2205 BL team, in data structures algorithms, there, number 5, under files, we have these 3 directories. Course materials has the PDF of most of the slides that we're going to go through this week, as well as a zip file that has all the code zipped up. Also, the data structures and algorithm book itself is in there. For the next today and for the next 3 days, there will be call outs to chapters in that book. We generally won't be looking at the book in class, but there will be call outs to it. And a lot of the material is derived from that book. So that's what we have there. But in Workspace, this is the directory that basically is an IntelliJ project already. We're going to use that, but we're going to use some other stuff as well. So to download this, if you just select that workspace, you can download, or you can go to the 3 dots over here and say download from there. That's going to create a zip file. And that you can see it's downloading my zip file right there. Now this is just like the stuff we did in the first 6 weeks. This is just a big kind of monolithic IntelliJ project that has a bunch of labs in it for the next 4 days. We're actually going to take that. We're going to get it set up. We're going to get JUnit set up in it. But we're also going to how best to say this? We're also going to deviate from that this morning. And because what we're going to do today is kind of self-contained. It's part of this, but we're not going to build on it much over the next few days. So we're going to kind of jump out there and just refresh your memory on setting up a brand new project, on setting up a Gradle project, on adding dependencies to a Gradle project, and so on and so on and so on. So we're going to do a little bit more review starting this morning, but more mechanics, how we just do these basic tasks. And it's still downloading. It shouldn't take this long to download, but whatever the hell. Yeah, I think the team server is now being tasked a little bit, or that's actually the SharePoint server is being tasked a bit. Yeah. Oh, it got better. There were a couple of days in the last cohort I did where Xfinity was dropping me off just over and over and over again. And we did have one more time when, just like that happened in this cohort, when one day our Adobe Connect classroom just locked up and we couldn't say anything, we couldn't do anything, we couldn't get back into it if we disconnected. And so that seems to be something that happens every few weeks with Adobe Connect. So watch out, Shaq. If it's not quite finished downloading, that can definitely be happening. So we'll take a look at that in a minute. But that's one of the typical things, is that if it's not finished downloading, there will be issues. We'll just make sure that everybody's got exactly the same size before we go to the next step. And it could be that as is often the case, that Microsoft SharePoint is partly to blame if there's some malformed stuff in that zip. SharePoint is not one of my favorite platforms, just as Adobe Connect is not one of my favorite platforms. And it got from 6 megs to 20 megs, and now it's spinning some more, spinning some more, spinning some more. Well, my favorite platform is the classroom itself. I would prefer to be in a classroom. I spent the last 2 years working with Zoom, and that was okay. I did the first cohort I did online after the lockdown started in my previous gig. I did on WebEx, and I hated that. I hated that with a white hot passion. So Zoom was a dramatic improvement over that, but Zoom has its own problems. So yeah, none of them are perfect right now. There are some features of Adobe Connect that I really like, but I like the ability to kind of compose and share a number of things and overlay them and stuff like that. something that's much harder to do in a platform like Zoom. But Zoom is definitely a little more approachable, and I think at this moment a little more performant. They're both hogs. They're terrible resource hogs. There we go. So if I bring in my downloads now, come on, where's my downloads? Why will you not show in folder? Oh boy. Okay, well, we'll just do this way. All right, so here's the workspace file downloaded. It looks like it has 27.6 megabytes of content. That works out to be that many bytes. So if you got something significantly smaller than that, it will, yeah, Shaq, it probably, the download probably choked at some moment. Yeah, because that's definitely, if it's got only that much, it'll definitely report an invalid format. It's okay. We got a few minutes. We're just gonna spend, so retry the download. We're gonna spend the next 20 minutes or so getting this all set up. And because Nadra is doing kind of an hour and then a 10-minute break sort of thing, we'll do the same thing just so we keep that same routine. So in about 9 or about 8:30 Pacific, we'll take 10 minutes. So. All right. So with that, fun. Well, let me try mine, see if I get the same problem, Henry. I already have it downloaded a different way, but let me try that. So if I extract all here, and I extract, and it's just zipping along, unzipping along, extracting. All right. So there should be one directory in the extract called workspace. And notice this is already a Git repository too. We'll see what it looks like when we open it up. We'll see what past commits there are in it. But it's already a Git repository. I can tell that because inside that workspace directory, I have a .git directory. If you're looking on OS X, you might not see that .git because it could be hidden. If you're looking on Windows, it could be hidden as well. So remember that there's a setting we can change in Windows to say don't hide things from me anymore. And then on OS X, we generally have to do it when we want to show things that aren't hidden. We do like a command shift period, I believe, to show hidden things. So this is what you should end up with. Notice it even has a .idea directory in this zip file. So this basically is straight up an IntelliJ project already set up. It's got an out directory, which probably shouldn't be in the repository because, yeah, we've got a lot of stuff in out that probably shouldn't be there, but we'll worry about that later. But these are all the labs. Notice the solutions and the starter code is in all of the labs already. We have a solution lab and a starter lab. So once everybody has this downloaded, start giving me a green when it looks like the whole thing got downloaded and you have this structure intact there. Yes, Wally, what can I do for you?
No. But that was an error. I wanted to the green light.
No problem. No problem. All right, so it looks like, so give me a thumbs up keep as you get it downloaded and unzipped, and it looks kind of like this. And just as you saw in the previous, in the first 6 weeks, we have a directory already in there that has the JUnit jar files. Yeah, I'm not a big fan of doing this, of including these jar files. When IntelliJ, and whether you're using a basic IntelliJ project or a Gradle project or a Maven project, it's absolutely capable of you saying, I depend on this library, and it will take care of making sure that library is available. So including the JUnit 4 and JUnit 5 directories here is a little weird. But whatever, we'll deal. We'll adapt. Okay, so we're still looking at Daniel, Ebenezer, Henry, Jack, Kita, Kyle, Nina, Sam, Shaq, and Shinar. Let's get all this downloaded and unzipped. So while we're waiting on that, any particular questions this morning about the review yesterday or about what we're going to work on today? Man down. I'm sorry, Shaq. So it's just not downloading for you? Not the whole file. Crap. Well, maybe what we'll do is we'll go ahead and do the lab ones today totally separately. You're going to need to download this and set it up. So let's actually, if you're downloading, that's fine, but let's start up IntelliJ, and I was going to create a project from scratch anyway for today, so let's do that. So let's fire up IntelliJ. If it's still downloading, let it download. You may if it's getting errors, you may try another download at lunch when we're not all trying to do it at the same time. So let's bring up IntelliJ, please. And let's create a new project. So I'll wait for everybody to get to this point. I'm going to clear statuses again. And if you're running IntelliJ 2021, that's okay. If you're running IntelliJ 2022, that's okay. We kind of know how to adapt between those two. So everybody give me a thumbs up when you've got IntelliJ open, you've clicked on new project, and you're ready to take the next step. Okay. Did in the Python section, what IDE did you use? Did anybody use PyCharm or what IDE was being used in the Python section? Visual Studio and Vim. Gotta love Vim. Yeah, PyCharm is a totally different world from Vim, but there will be times when you need to use Vim. There will be times when you're connected to a remote host and all you've got are the basic text editors like Vim and a few others. So yeah, Vim and Emacs and Pico and things like that. Totally old school. Totally old school. Actually, Vim is less old school than what it was based on, which was Vi. And you can still use Vi too on some systems. And yeah, that's not a super fun experience. Okay, so I'm looking at Daniel, Kyle, and Robert. Are you guys set to go with IntelliJ? Give me a thumbs up if so. GDB. Okay. So actually, that's fine. If you've downloaded, that's fine. But we're going to shift gears here because everybody's having so many problems downloading with errors, downloading without errors. So we're just starting up IntelliJ. Go ahead and start up IntelliJ, and we will we'll go from there. Oh, did I tell you the old horror stories about old versions of Fortran, Robert, where when we passed integers by reference and you could actually change the value of a literal integer? So yeah, not a great thing. All right. Okay. So I think we're ready to go. An atomic integer, I love. Atomic integer is a great thing. Robert, are you ready? You have IntelliJ fired up? Okay, fantastic. All right. So I'm going to clear everyone's status again. So we're going to create a new project. And this new project will be what we're going to use for doing the first few labs, the binary conversion. So that's what we'll call this. We'll actually just call this conversion. So make sure you're in the right directory. So you may need to change. I need to change. You may not need to. I need to change back to my 2205 and DS and A. There I am. And then I'm going to call this conversion. Okay, actually I'm going to name it in lowercase because I like directory names in spinal case, but you can do it whatever you want. And if you're using 2021, you don't have this option to create a Git repository right away, so we'll do that after we create it. If you're using 2021, then over on the left-hand side, you want to click on Gradle. I apologize for not saying that earlier, but on the left-hand side, you want to click on Gradle. If you're using 2022, then we select Gradle right here in the build system. It's still an IntelliJ project, but the strength, if you may remember that one of the things I mentioned about the strength of doing a Gradle project is you could open this Gradle project in VS Code, you could open it in Visual Studio itself, you could open it in NetBeans, you could open it in Eclipse, and it would still work just fine. There's no import really necessary. All right, so make sure it's a Gradle Java project. If you're using 2021, you're going to have to go back and forth between two screens to do some of the things we're talking about here. Make sure that whatever the name of the project is, that when you look at the location of that project, down here in 2021, you'll see it right there. In 2022, you'll see the final location in gray here, right there. Okay, so make sure that it is the right place, that this location ends with conversion, that it ends with conversion. In 2021, that will be right in the field itself. In 2022, it will be in this gray text underneath. And this will be Java, of course. If you're using 2021, you don't need any other languages. So you don't need to click any of those other checkboxes. And we're going to use the Groovy DSL. So in 2021, there's a checkbox to say use Kotlin DSL. You don't need that. In 2021, there is an artifacts, I think it's on the second screen, in artifacts settings. In 2022, we have these advanced settings. And in the advanced settings, let's change our group ID to com.tlg learning. If you remember, in a Maven, we're using Gradle, not Maven, right? Yes, but Gradle works with a lot of concepts that were introduced in Maven, such as Maven coordinates. And in Maven coordinates, we have a group ID and we have an artifact ID. So our group ID here is going to be com.tlg learning, and our artifact will be conversion. Generally don't have to modify that because it comes straight from here. In 2021, there's a version that's there. It's 100 snapshot, I believe. You can leave that exactly as is. All right, let's create this thing. And your build Gradle is going to look familiar. And remember, a little couple of distinctions we want to remember. This is a file, build.gradle. It is the build script. It basically defines how the build will be executed. There's a directory called .gradle that holds temporary cache data for Gradle. That one is not an essential directory for us to include in our repository. There's also a directory called Gradle. That one we do want to keep. We do want to keep the directory called Gradle. So after this whole thing fires up, you should be looking at something like this on the left. In the project tool window, you'll have a .gradle directory. You'll have a .idea directory. You'll have a Gradle directory. Notice that one doesn't have a dot at the start. Got to distinguish between those. And notice those are directories. Those aren't files. Those are directories or folders, whichever you want to call them. And source, and then our build.gradle. That's what we're looking at right here. This is a file. So a lot of times I'll say, hey, you want to ignore or delete the .gradle directory. And they say, well, I've got something called build.gradle. I say, that's not it. .gradle is a directory. Build.gradle is a file. And you've got all these other files. And to refresh your memory, in settings.gradle, that's where we actually have the artifact name. That's set up in Gradle as the project name, is the artifact name. If your source folder didn't populate, that's okay. Make sure that you wait until, don't worry about it until everything down at the bottom is done. So if you're still seeing a progress bar at the bottom saying importing project or building project or anything like that, you let that go. It's only when it's all done that we need to do anything about it. All right. So give me a thumbs down, please, if some part of this, the Groovy plugin, that's okay, but it's not a problem if you've got it. But that's mostly if we want to write our own code in Groovy. I mean, the build.gradle is a Groovy file. But yeah, the Groovy plugin's not a problem. But when we want to do things like write our application code or our library code in Groovy, we use the Groovy plugin. All right, give me a thumbs down if something choked, like if you don't have inside source a main and a test, and inside each of those a Java and a resources. Please don't jump the gun on creating a Git repository. We're going to create a Git ignore first. If you already checked that box, if you're using 2022, you check that box to create a Git repository, that's okay, but we're going to do some stuff before you do any commits. So give me a thumbs down if you have something that looks radically different from what I've got here. I was going to say I'm so happy, but apparently we've got one issue. So let's go ahead and Augustine, could you do me a favor and share your screen? So the things that can go wrong when creating a project. All right.
Yep.
So what I'd like you to do.
Okay.
Yeah. So what I'd like you to do is click on the conversion directory, the root of the project. And you're going to right click on that and say new directory, please. Yep. And notice that it knows there are 4 directories missing. So you can go ahead and click those and just hit enter now. And then, yeah, there you go. But I don't know if it'll do all four. I did all four at once. Fantastic. There you go. That's it.
Awesome. All right, appreciate
Yeah,
it.
it's some if something happens where it gets interrupted for some reason in that process, that can happen.
Okay.
All right. All right, folks. So now let me share my screen again, and we will take care of some housekeeping. So if you recall,
Hey, Nick.
question?
Yeah, I'm looking at my build.gradle and I don't have the file. Let me see. Okay, no, I'm good. Everything is fine.
Okay, good. Fantastic. Glad to hear it. Okay, so we're going to do some housekeeping. So remember that if we don't tell Gradle what version of Java it should use, then it will just use the Java home. And some of you have machines that might have Java 17 installed, Java 18 installed, or something else. And we're going to use Java 11 for this. So if it's using the Java home, we could get different results. Generally not that serious, but you want to make a habit of saying, I want to specify the version of Java that I want Gradle to build this under. So right here after the Java plugin, please, in the build.gradle. So I'm coming right there. I'm not inside the braces of plugins, and I'm above group. So I'm after the closing brace of plugins, and I'm above group. And we're going to do the, we're lowercase j Java, and then curly braces, please. So with the Java plugin defines a number of tasks that are now available to us, that become available as Gradle tasks. And the Java plugin is just one of many plugins we might use. In fact, there are a number of standard plugins that build on the Java plugin. There's a Java library plugin. There's a Java application plugin. There's the Android plugin that builds on top of the Java plugin. But when any of these plugins define tasks or customize tasks, or they include a way to customize what that plugin does. And that's exactly what we're doing now. We have the Java plugin. We now have this Java, lowercase j, please, in this case, and then a set of braces. And inside these braces, we can customize the configuration of the Java plugin, the basic core configuration of it. We can also customize the tasks that are included in the Java plugin. But for now, let's just go ahead in Java and then one word, all lowercase. Tool chain is generally not treated as two words in camel case. So inside here we have tool chain, and as you start typing, it's going to be suggested. So just pick this one that's just tool chain by itself. And then another set of braces. Now, here's something fun. You may remember, and you may have it on your own screen, that IntelliJ is displaying this Java toolchain spec, it. And then, and this is just a hint, this is just IntelliJ displaying this. And then something that looks like the lambda operator. It's a lambda. What we're putting inside this toolchain is, we're specifying a lambda, a toolchain lambda. And in Kotlin and Groovy, when a lambda takes a single parameter, in most cases, we don't even have to define that parameter, and it will be referred to automatically as it or this, depending on which language we're using. In Kotlin, we get both it and this sometimes. So in fact, there is this parameter called it that I can refer to, but I don't need to here. But that's a lambda. All right, now what we're going to set inside this tool chain is we're going to set the language version. So if you immediately start typing language version, you'll see it come up there, language version. Remember, don't use that as a model to type. take the suggestion. Look for the right suggestion. Look for the suggestion you want. But taking the suggestion reduces the opportunity, never eliminates it, but reduces the opportunity for easily avoided typing errors. So language version, and then equal. And then we're going to invoke, we're basically going to invoke a static factory method of a class called Java language version. That class is built into the Gradle library, or built in the Java plugin of the Gradle library. So uppercase J, this is a class name, remember. Java, and then uppercase L, and you'll see Java language version. So remember, static methods we invoke with the name of the class. We can invoke them with an instance, but there's no point in doing so. So we invoke them with the name of the class. So the class we're referring to here is Java language version. Then the method we're invoking is called of. So OF, and then in parentheses 11. That's how we tell it. We're going to use Java 11. That tells Gradle, I want to use Java 11 to build this. If you did this on a machine, here's a nice thing. If you did this on a machine that had Java, let's say Java 8 installed, and you gave it a Gradle file like that, Gradle would automatically download Java 11. All right. Let's move down just a little bit to our dependencies. We will be doing unit testing today. Did you do much unit testing in the JavaScript and Python modules? You don't have tool chain in what sense? Like it's well, there has to be a JDK because Gradle is itself a Java program. Gradle is written in Java. So there has to be a JDK, but if you don't have the right version, it will install the right version. All right, Sam, let's go ahead, do me a favor, and I'm going to make you a presenter. And go ahead and share your screen. Let's make sure we're all up to speed on this. All right.
Okay, can you see my screen?
Yep. So on line 6, what's happening is you're typing tool chain and it's not coming up as a suggestion. Aha. Interesting. Interesting. Do me a favor and backspace over the word tool. And I'd like you to go up to your Gradle refresh thing. Let's just see what it's choking on. Yeah, this looks like yeah, go ahead and refresh that. And now start typing tool. Let me see what we get.
Never mind, it's there.
Yeah. There
okay, thank you, Nick.
No sweat. No sweat at all. Nadra is joining us for a little while today, so welcome, Nadra. The reports from yesterday's review were very positive, Nadra. I think you put them in good shape for this week. Okay. We're going to share my screen, and we're going to just wrap up the Git side of this. Well, we're going to do a little bit on our unit testing setup, and then we're going to wrap up the Git side of this. And we will, again, go back to that workspace you downloaded that was having errors a little later, because we just don't need that at the moment. But we will go back to that so that you're in good shape for tomorrow with Nadra. Yeah, the dot Gradle is something that doesn't necessarily happen right away, so don't worry about that. All right, inside your dependencies, please. Inside your dependencies. Let's go ahead and we're going to define a Gradle variable. We're going to say def JUnit version. And remember, this will be a string inside single quotes, and it will be 5.9.0. JUnit 5.9 was released a little while ago. I'm not. We've had a lot of discussions between instructors over the past couple of weeks about this. I'm not a big fan of version chasing, but for minor release updates, generally we should take advantage of those. They're generally bug fixes, and that's a good thing to take advantage of. All right, so Def Jayden, don't notice that I didn't type the colon string, just to refresh your memory. That's a hint that IntelliJ is displaying that we can turn off. We can turn off those hints by going into the settings and turning off what are called inlay hints inside IntelliJ. Then we're going to change something in these next two lines. So I would like you to, after the Jupiter in this first line, get rid of the dash API. You got to keep the colon. You have to keep the colon. But the dash API can go away. Now, we're not going to put 5.9 directly in here. In fact, you'll notice that IntelliJ is probably telling you that this 5.8.1 can be updated to 5.9. But we're not just going to put 5.9 in there. What are we going to do instead? We're going to use the variable we declared, and we're going to do string interpolation. But string interpolation in Groovy requires double quotes. So please, on both of these lines, the test implementation and test runtime only, my lines 20 and 21, change those single quotes to double quotes. If you're using IntelliJ 2022, it's really, really simple to do that. And then replace the 5.8.1, but not the colon. You got to keep the colon there. Replace the 5.8.1 with $, then JUnit version, and it'll come up as a suggestion in most cases. Again, it's a little better about suggesting things like that in 2022 than 2021. $JUnit version, like that. We're going to make one more Gradle change. One more Gradle change. And that is in the Gradle directory. Inside Gradle, not .gradle, Gradle. Inside Gradle, we have a wrapper. We have a Gradle wrapper .properties. And I would like you to change whatever's showing there. You've got a number, you've got 7 point something, or maybe even 6.9 something. But I want you to identify just the number part, not the dashes, not the bin, just the number part. Look at what I have selected. And make that 7.5 instead of whatever version's there. Once you've got those in there, go ahead and click your elephant, monkey, dinosaur. And we're going to look for errors. Going to look for errors here. We're going to look here. We're going to pay attention to error messages. We cannot afford to just ignore them. We cannot afford to get tunnel vision in our code. We have to be looking at the entire workspace to look for problems. When a problem occurs and we let it go and we keep going and we just don't pay any attention to it, we're digging ourselves a hole. It's just that little icon up in the upper right, Robert. It's actually an elephant, but one of my past cohorts called it an elephant, monkey, dinosaur. So, or they argued about it. They said, it looks like a monkey to me. And somebody said, it looks like a dinosaur to me. So after that, it was our elephant, monkey, dinosaur. Man, bear, pig would be a good approximation. That may be my new name for it, especially after the South Park 25th anniversary show last week. Man, bear, pig. All right. If you remember that if you don't see that, you can always go into your Gradle tool window on the right-hand side, or remember you can get to any tool window in IntelliJ under View, Tool Windows. All of your tool windows are there. And you can just click this refresh right there, and that will do the same thing as clicking on that icon. So if you don't see it, can't find it, whatever reason, if you don't see the Gradle tool window at all, then you may need to basically close the project and reopen it in such a way that it forces IntelliJ to wake back up. Yeah, it's a build system. We have three classic build systems in the Java world. Okay, the first was Ant. And Ant is an XML. You write your scripts in XML, kind of like Maven, but it is fairly low level. Then you have Maven, and Maven is about really very high level. These are the dependencies, and everything in Maven, most everything in Maven, you have to use plugins to do anything. And there's not really a built-in scripting facility, or it's not readily accessible scripting facility in Maven. So Maven is very much a highly opinionated build framework. It says, this is the way builds have to work. And if we want to change that, we have to do a lot of work to change that. Gradle occupies the middle ground there. Gradle has a lot of characteristics of Maven and actually followed very soon after the introduction of Maven. But it's also much more readily scriptable than Maven is, so kind of like Ant. In both of those, by the way, both Gradle and Maven, you can incorporate elements of Ant into it because Ant's built in Java too. So it's actually fairly straightforward to incorporate elements of Ant. There's build.gradle. Any specific spot in that you want to see, Ken? Right there. Watch the casing. Casing's just as important in Groovy as it is in Java. So that's a lowercase j Java. Remember this here, the Java toolchain spec, it's just a hint. It's not anything you type. Just a hint that's being displayed. And you may not have that hint on your machine. Depends on how you've configured IntelliJ to show hints or not. Toolchain is lowercase. Java is lowercase. Language version is lower camel case. All right. So now, please run the dependencies task. So you do that. Notice that these tasks in Gradle become executable. Like your main method shows a little green triangle. So if you click on that, on the green triangle next to dependencies, you can run that task. And what you're looking for is some build unsuccessful or some error message. So build successful is what Gradle shows us when some task succeeded. Not necessarily building your Java program or running it, but the task that you told Gradle to run. When it succeeds, you're going to see a build successful at the bottom. So did anybody get a build failure or some kind of error message here? So Jack, what I did was I went to, in build.gradle, I went to dependencies. I see the green triangle there. I clicked on that and said run it. Sam, let's go ahead and have you share your screen here for a moment. And let me stop my sharing. And go ahead. All right. So here we see, so the problem is it says, you need double quotes on lines 20 and 21 instead of single quotes. Remember that in Groovy, double quotes are used for string interpolation. So you've got to have double quotes around both of those strings, not single quotes.
Okay. Is that something we changed?
Yeah, we changed that. We changed that.
Okay, I think I missed that one.
It's okay. This ain't Python. This ain't Python. In Python, yeah, we've got double quotes and single quotes are generally interchangeable, but we still have conventions. So in Python, you'll find that a very common convention is to use double quotes in user-facing strings and single quotes in strings that the user never sees. That's just a convention. We could use double quotes for everything in Groovy, and it would be fine. But a lot of times we use single quotes if we don't need string interpolation, and we use double quotes if we do need string interpolation. All right. Anybody else have any errors on this? When you ran the dependencies task, if you got any errors, let's take one more look at that. Looks like we're okay. Looks like we're good. All right. So last thing, let's do the Git part of this. So if you did this in 2022 and you check that box to create a Git repository, you've already got a git ignore file. I'd still like you to change it though. So otherwise, what I'd like you to do is go to the root. If you don't have a git ignore file yet, go to the root. That's the directory right here, conversion. That's the root of the project. It's not the root directory of your file system. It's the root of the project itself. And I'd like you to create a new file. And remember all the different ways we can create files. We can right-click there. We can go up to the File menu and say New. Or on OS X, you can do a Command-N. On Windows, you can do an Alt-Insert. And both of those bring up what would appear in the new subdirectory. And we're going to create just a file, not a directory, not a Java class, just a file. And this file is going to be named very specifically. Please pay close attention. Hopefully you remember this. Hopefully you've been using this. It starts with a period. It's the .gitignore file, and it's all lowercase. It's not two words. It's not camel case. It's no uppercase character in there. And it's got to start with a period. If it doesn't start with a period, it will not work as intended. It will just be a file. It's the special name of .gitignore that makes Git treat this file in a particular fashion. Now, if you already had a .gitignore file, that's fine, but we're going to change some things in it. Because we really don't want, as a rule, especially when we're doing a Gradle or Maven project, we don't want the .idea directory anywhere in the repository at all. We don't want it there at all. So what we're going to do in this gitignore is the first thing we're going to ignore is .idea/. That says a directory. The slash at the end says directory. A directory named .idea anywhere in the project is going to be ignored. If I put a slash at the front of it, that would mean a directory in the root of the project will be ignored. But .idea/. So if you created a Git repository when you created the project itself, then you've got a bunch of lines that say .idea/something, .idea/something, .idea/something. You can get rid of those and just put that in there. As long as you haven't committed yet. If you've already committed, then we've got an issue. So just do .idea, please. Then build. So we don't commit to our repositories things that are built by our project, with a few exceptions. Sometimes, as you probably recall, we might generate our Java doc content into a different directory that will be committed. So that's a build product, is the Java doc HTML and CSS and JavaScript. We don't even always do that. So, but in general, everything in the build directory we want to ignore. And finally, .gradle. And notice that's not build.gradle. It's .gradle, all lowercase. It's not without the dot. Please make sure you got it with the dot. So those are the 3 directories we're going to ignore. There's a whole bunch more we could ignore, and when we let IntelliJ generate its own .gitignore file, which it will after our first commit, it's kind of annoying, or after we create the Git repository, it will. It'll put a whole bunch of other stuff on there, and that's fine. All that stuff is good, except that it's not strict enough about that one. We generally don't want to include anything from .idea. But there are a few other things we do want to leave out. I'm going to leave out *.iml. So depending on the way we open this project, IntelliJ might create an IML file before it figures out that it's a Gradle project. Yeah, we don't want an IML file. I'm going to leave out, because I'll probably use flubits today, I'm going to leave out .flu*. So remember, the asterisk is a wildcard here. It says any file that ends with the name .iml. In this case, it's any file that starts with .flu and then has anything after that I'm leaving out. You don't have to have that, but I'm going to put it in there because I don't want to include any flubits files if I share things on flubits with you today. And now the one for, do this whether you're using OS X or not. You want to include this. And it's already included if you already had IntelliJ create the gitignore. Go ahead and do a .ds, that's uppercase ds, then an underscore, then the word store with an uppercase S. These are simply files that, if we include them in a repository, can cause needless merge conflicts if we share the repository. Now, this repository we're only going to be using ourselves, but we were talking about building habits, building practices. And one of these practices is assume that somebody else you're going to be collaborating with somebody else in a repository. All right, now let's go ahead and go to the VCS menu at the top of the screen. If you're on OS X, it'll be pushed a little further to the right. In Windows, it's just right there after Tools. In OS X, it's kind of bumped out to the right usually. So go to the VCS and go ahead and share your project on GitHub. That's going to create a local repository. It's going to create a repository in GitHub. Then it's going to ask you what files you want to include in your local repository. Then it's going to do the commit. Then it's going to push that commit to GitHub. So the first thing it asks me is what the name of the repository in GitHub is going to be. And by default, IntelliJ shows that as the name of our artifact. The name of our artifact. If this were a plain IntelliJ project and not a Gradle one, it would be the name of the root directory of the project. But this one is coming from our settings.gradle, where we have the name of that artifact. Yep. So that is under VCS, share project on GitHub. If you already checked the box when you created the project, if you're using 2022, and I said, please don't check this box, if you already did it, then you don't have a VCS menu, you've got a Git menu. And you'll have to go under Git and go to GitHub. But we're sharing the project on GitHub. If you don't have a local repository already, it will create one. If you do, it'll say, fine, there's one created. But then it asks us what we want to commit. And notice that because I've got that gitignore, I don't see anything in here from my .idea directory. If you see something from .idea, I want you to uncheck it, please. Should be nothing here from .idea or .gradle. I'm not talking about build.gradle. I want to be absolutely crystal clear on that. Or settings.gradle. Those we want. But there's a directory called .gradle that I don't want in my repository because it's just temporary cache information. It doesn't make any sense to make that part of my permanent repository. Same thing with the contents of .idea. Same thing with the contents of build. And then I'm going to add. And eventually you'll see this thing down at the bottom. that says successfully shared on GitHub. And if you click on that, you'll actually go out to GitHub and you'll see your repository you just created. Notice that it doesn't have the source directory there yet because Git doesn't remember empty directories. So that means it doesn't remember the source main Java and source main resources. Therefore, it doesn't remember source main. It doesn't remember source test Java or source test resources. Therefore, it doesn't remember source test. And because it doesn't remember source main and source test, it doesn't remember source. That's okay. That's not fatal at all. All right. This is a good time for a 10-minute break. We'll take another one about an hour after we come back. So if you're stuck on something, stick around for a minute or two. Otherwise, I'll see you all in 10 minutes. If you've got questions or stuck on something, feel free to ask. All right. See you all in 9.5 minutes or so.
Nick, I got a quick question.
Yeah. Question.
Oh, okay. Maybe I'll just send you an email. But do you have any recommendations as to what good resources to learn Spring Boot and then Makito?
Ooh, yeah.
Android.
So the first thing is there's an online site that is the definitive resource for Spring and Spring Boot. First off, the Spring site itself is actually pretty good, but it's not really written in such a way that it's terribly approachable. It's got a ton of information, a ton of really good information. But Baeldung.com, BAELDUNG.com. I'll type it right here.
Right.
Baeldung.com.
Oh yeah. I've used that. It's a little bit of all over the place. I want to say maybe because the way I searched it. Yeah, like I've used it for learning.
It's got a ton of info there, but yes, depending on how you search it, you'll find all sorts of things that may not necessarily be exactly what you're looking for. But those basically that's the Bible for how to use not just Spring and Spring Boot, but how to use JPA, Hibernate, how to use a lot of Jakarta Enterprise as well. Basically, it's the Java Enterprise that they've got fantastic tutorials. They've got some you got to pay for. In fact, they're very extensive tutorials you got to pay for, but they've got a bunch of free tutorials as well.
Right.
That's the first place I would go. Also, Manning is a good publisher for books on a variety of topics related to development, including Spring and Spring Boot. So Manning.com is a great source for books, and they run sales all the time where their ebooks are generally discounted, 40, 45, sometimes 50%. So Manning is really good.
All right. Yeah, I'm trying to do a. Would you recommend going straight to Spring Boot instead of like learning everything about Spring Framework?
Yep. I would go Spring Boot right away rather than Spring.
Okay.
So first off, Spring Boot incorporates Spring. Spring Boot incorporates Spring, but it also includes it's kind of a best of breed sort of thing where especially if you use the Spring initializer, you can build a project that has a number of best of breed libraries. So Hibernate, Jackson for JSON serialization, Spring itself, and then Spring Boot kind of ties it all together with an auto configuration mechanism. So I would go straight to Spring Boot. I wouldn't really bother with Spring itself.
Let's get even up, but yeah, I'm trying to build a Spring Boot project with React and do everything else through AWS. So that's my personal project.
Yeah, and that is a very widely used approach. I would do it, and so I may even have a couple of examples I can send you. I can send you links to where with We did.
Yeah.
I did some training. Did they do it with React?
No, it doesn't
I
matter. I
can't.
can react on my.
Yeah,
No, that's
I
fine.
did some training 2 years ago or a year and a half ago with a government agency here in New Mexico, and I think we did a Spring Boot application there that was Codebreaker, um, uh, using emojis, I believe, and
Oh.
I think their front end was React. So I'll see, and I'll
Yeah,
send
let
you a
me
link
send you a
if I see.
link. Yeah, let me send you a link. Yeah, I'll just probably get yeah, I won't hold you up on the break. I'm gonna take us on break
Okay.
myself, but yeah. Okay, that
Okay.
sounds good. Thanks.
Sounds good. Yep.
Sorry, he said he won't hold you up. I don't intend to hold you up either.
That's okay.
But with my GitHub, when I committed, I think I had a few more things selected. So when I go to GitHub, I actually don't see the conversion. I see most of what all we did
Can you show
yesterday
me?
on there.
Yeah. Can you show
Yes.
me? Yeah,
I
you have
cannot
to be
share.
really careful that you don't create a Git repository in a parent directory so that it contains multiple projects. That's a recipe for disaster. So if you can share, that would be great here.
Okay. Can you please give me sharing
Yep,
access?
you should have share access.
No,
You're a
this
person.
Ebenezer, please. I don't. Ebenezer.
You are a presenter.
Oh, really?
Let me make you. I'm going to clear it here for a second. So, has your machine? Well, it can happen that if you're in a breakout and you're present. Were you ever a presenter in a breakout yesterday?
Yes.
So what you may need to, but you probably quit Adobe Connect since then, so it shouldn't be a
I
problem.
did quit.
So try it again. You should see up in the upper left. You should see that button to share your screen. Do you not see it there?
You mean where the three dots are? When I click them, I only see the help.
No. I'm talking about
And
upper left of the main white area in the middle of the screen. Upper left of that, you should see a screen button that you can click on. He is a presenter.
I think Wale is a presenter.
Oh, sorry.
This is
sorry. Yep, you're right. You're right. Go ahead. Go ahead.
Okay.
Yep. So this is a problem. So you want to be super careful about this. It looks like you created your project here without creating a separate conversion directory. So what I need you to do is I need you to go under settings here, please. Just go ahead, settings right now. Do you see settings? I want you to go all the way down to the bottom. I want you to delete this. This is one of the big things you have to always be on the lookout for, is you want to create an IntelliJ project in its own directory, not just in the parent directory. Now, please show me your Windows File Explorer. Okay, and so stop for a second. Whoop. So now open up that conversion directory, please. I want to make sure we've got that. Perfect. Perfect. Now, go into IntelliJ, please. Actually, do me a favor first before you do. Yeah, go into IntelliJ, sorry. Go into IntelliJ and close the project. So do a file close. Now, go back to, don't open anything. Go to File Explorer again, please. All right. Please go ahead and delete .gradle and .idea. Now, go back to the previous directory, please. And one more, please. Because it looks like you created a .git directory containing everything. Yep, see that .git directory? You got to get rid of that. That is going to cause you no end of problem. Git repositories live in the projects they're in. So now go back into IntelliJ, please. Reopen the project. Now, after it's finished opening, we're going to create your repository again. We're going to share on GitHub again, but we want to be very careful about what shows up. So under VCS, please. Yep, under VCS, please go to Share Project on GitHub. Now, go ahead and click Share. Perfect. Now click Add. So I don't know exactly what you did. I don't know if you created your repository and then shared it, but you created it in the wrong directory. That's what it looks like. But you've got to be, that's one of the things that is going to cause you no end of headache if you have multiple projects inside a Git repository. That's what you had here. It looked like you created the repository directly in the TLG directory. So you want to just want to be one of the things that you want to watch out and avoid. Go ahead and refresh this, please. Oh, that's okay. Let's go back.
Oh, you mean
do you have
on GitHub?
Go to the link. No. That's sure. Refresh this. That's fine too. There. There's your conversion. Open that up, please. There we go.
All right. Thank you.
Yeah, no sweat. You just want to be that's one that's not fatal, but you want to correct it immediately. So I'm glad you brought it up. I'm glad you brought it up because it's one of those things that's just going to cause so much problem because now you would have a repository that has everything you've done in it in one repository. Sometimes people say, well, why shouldn't I do that? Well, that makes it almost impossible to manage a project if you've got 10 projects inside one repository. So, yeah, that's all.
I did not know when that actually happened, but I was actually thinking of creating a master folder that contains a lot of the projects that happen.
And that's fine. That's fine. Just don't make it a repository. Just don't make that folder a repository. That's all.
Why not?
Because you won't be able to manage your individual projects in separate repositories. Git does not support one repository nested inside another at all. At all. So
because
you wouldn't be able to. Go ahead.
I was going to say when we worked on Python, we had a directory called my code, and almost everything was within that directory. And I was contemplating whether to
that was for a week. That was for a week of work. When you're dealing with projects where you have multiple distinct projects that have their own life cycles, and you're going to collaborate in those, and again, make that assumption from the beginning. Make the assumption from the beginning that you want the ability to invite people to collaborate in your repositories. And if you give them a repository that has all of your work in it, that makes it very difficult, very difficult. Also, when you create a branch, you can't create a branch based on just one directory. You're creating a branch of the entire repository. So if you've got project A, B, and C all inside one repository, say, oh yeah, I need to create a new release branch for project A. I'm going to call it version 1.2 or something like that. Well, no, you've created a branch of the entire repository, not of that one project. So yeah, it's not a good practice at all, at all. For quick and dirty stuff, I'm going to create. In fact, for example, I'll give you the use case where what you just described actually makes perfect sense. Makes absolutely perfect sense. So if you're working through a textbook and it just has a bunch of small projects in it, nothing major, nothing that's carried over into multiple chapters, then it makes perfect sense to create a repository for your work on those problems and just put all of them in there. But anything that itself needs to have a life cycle of its own needs its own repository. A development life cycle of its own needs its own repository.
Great, thank you.
Yep, you're welcome. All right. You are very welcome, Ebenezer. Let's resume. Welcome back, everybody. Please clear your away status if you were away. And let's get to work. So we're going to talk about a specific problem. Let's go back up here. And there we are. We're going to talk about, we've already talked about what an algorithm is. I'm not really going to talk much about what an algorithm is, except to say that anything, almost any recipe or series of steps to produce something is an algorithm. But algorithms have different levels of power. And a powerful algorithm is one that is general enough that it can be applied to a wide range of inputs. So when I go to Google Maps and I say, show me the directions from here where I am at this moment to my favorite Mexican restaurant. The directions are a kind of algorithm, but they're not terribly general. They're really only good for getting me from point A to point B. Now, Google Maps itself has some very powerful algorithms in how to come up with those directions. But when we're talking about algorithms, we're talking about not only a series of steps to solve a problem, but a series of steps that are general enough they can be used to solve a type of problem with a variety of inputs. That's a much more powerful algorithm than one that just solves one very specific problem with one set of input data, and that's it. That's not a very flexible way to go. So when we're talking about algorithms, we're talking about general sets of instructions that can be used to go from some initial conditions, and those initial conditions we state in the algorithm. So when we talked several weeks back about the card trick that we did, we talked about, and I had you write the instructions of the video, and then we worked on actual pseudocode for that, and we built our code from pseudocode. The pseudocode included the initial conditions. We're going to start here, and we're going to end up here. And we know we're done when some condition is satisfied, or when some condition is no longer true. That's kind of a while loop is what that would be. But a powerful algorithm allows me to have a range of input values, clearly specifies input conditions, starting conditions, clearly specifies terminating conditions. How do I know I'm done? Some algorithms don't always succeed. So they need conditions that tell us, yep, you can't get there from here. This algorithm cannot be used to solve this problem for these reasons, usually. So that's all it is when we kind of extend our understanding of a problem-solving procedure, or a procedure to produce some specified outcome or find an answer to something. When we expand on that to say, well, I'd like it to be general so that it can solve not just this one specific problem, but a class of problems. And when we have initial conditions that the algorithm includes, this is what we need to start. And the algorithm includes conditions that I can check that tell me when I'm done, or when the algorithm cannot continue for whatever reason. All of those are part of what makes an effective, powerful algorithm. So the difference between a recipe that you find to cook a particular dish and a recipe you might have if you're a mess management specialist in the Navy is that typically when you go to your cookbook and you find, or you'll go online, you find a recipe, it'll say, well, this makes 4 servings, and you follow the instructions and it makes whatever it makes. Whereas if you're doing a recipe that would be followed by a mess management specialist in the Navy on board ship, or the equivalent in any branch, of course, you've actually got formulas that say, okay, take the number of people you have to cook for, and plug this in this way. Or they'll say, okay, you need to have one egg per person that you're going to feed needs to go into this recipe, whatever it is. So it is explicitly written in such a way to take a wider range of inputs. So there we're getting more into a flexible, more general, more powerful algorithm. All right. So the algorithm we're going to start with today is the algorithm that goes from a representation of a number in some base other than 10 and tells us what the quantity is. Here's the part that I want to make sure we're clear on right from the start. And that is, when I convert a number from one base to another, I'm not changing the value. I'm not changing the quantity. If I have 42 bricks sitting here on a table and I write that as 4-2, I'm not sharing anything yet. I write that as 4-2. That's a base 10 representation. But if I write that as 2A, that's a base 16 representation. The number of bricks doesn't change at all. At all.
Nick, are you sharing your screen?
I'm not sharing anything right now.
Okay.
I'm talking. I'm not sharing anything right now. The number doesn't change. When we go to different number bases, all we're changing is the representation. That's it. And the computer itself has an internal representation that is base 2. That doesn't mean we can't use base 10, obviously. We've been using base 10 all along. So I want to distinguish between a representation of a value, of a quantity, and the quantity itself. They're different. The quantity itself, I have here a bottle of ibuprofen. Probably got, thinking in base 10, I would represent it as about 250 capsules in it. Yeah. And, or gel caps, or whatever they're called now. About 250 of those. But 250 is a representation of the quantity that's in here. It's a base 10 representation. But I could represent the exact same quantity in base 2, in base 8, in base 16, in base 3, in base 6, in base whatever I want. It doesn't change the number of gel caps that are in this bottle. Okay? So what we're going to work on right now is working from a representation of a number in base 2 and converting that to a representation in base 10, or actually identifying the underlying quantity for that representation, which, because of our upbringing, because of our cultural background, we think of in base 10, and we get confused. We think of base 10 as being the number. It's not. It's a representation. That's it. That's all it is. So it's a convenient shorthand for us to say, well, when I take this base 2 number, I get this. If I convert it, I get this. Well, yeah, that's the base 10 representation you've created, but it's still just a representation. So we need to understand a little bit about positional notation first to go forward with this. And you've been using positional notation ever since you learned how to carry the 1. So when you first learned how to add numbers together and carry the 1, you were also told, oh, well, this is the 1's digit, and this is the 10's digit. And then a little later you learned this is the 100's digit, and this is the 1000's digit. That's positional notation. So now I'm going to share. So let's go to Docs. And I'm going to create a spreadsheet. So when we see a number like, I'll take 250 since that's what I was using as an example. That's really 3 digits in 3 positions. These are my 3, let me share my screen. Come on, mouse, there we go. All right, can everyone see my spreadsheet? I've just got 3 digits in there, 250. Let's make it more interesting. Let's do 257, just to make it a little more interesting. All right. Well, as I said, when we first learned in, whatever age, 5, 6, 7, 8, whatever age it was, when we learned that numbers were bigger than just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We learned, and especially when we started learning to add numbers together, we learned that this is the ones digit, this is the tens digit, this is the 100s digit, and so on. Well, I'd like to invite you to an additional way of viewing that. And this is 10 raised to the 0 power. This is 10 raised, I'm just going to use the caret for raising. 10 raised to the first power. And this is 10 raised to the second power. Okay? That makes sense? That 10 raised to the 1 is 10, 10 raised to this 2 is 100. What may not be as clear is that 10 raised to the 0 power is 1. Okay? 1 raised to the 0 power is 1. Negative 1 raised to the 0 power is 1. There was a convention that I mentioned in class when we were talking about multiplying numbers together. We probably talked when we talked about factorial at some point. That we have in mathematics something called the zero product convention. When we multiply things together, but there's nothing to multiply together, we treat the product as 1 rather than 0. So if you think about 10 raised to a particular power as being that many 10s in a row multiplied together, so 10 to the second power is 10 times 10. 10 to the third power, 10 times 10 times 10. 10 to the first power, 10. 10 to the 0 power? Well, let me modify those. 10 to the first power, 1 times 10. 10 to the second power, 1 times 10 times 10. 10 to the third power, 1 times 10 times 10 times 10. Now, is it clearer that 10 to the 0 power we're going to treat as 1? That makes sense for everybody? Fantastic. Fantastic. So, we can think of this now as 2 times 100 plus 5 times 10 plus 7 times 1. That's positional notation. In fact, we can go further. We can go into decimal point, to the right of the decimal point. And so if this is 10 to the 1 power here, what would be the next one after the decimal point? What would be the next power of 10 to deal with? We have 10 to the 1, 10 to the 0. What would go there? 10 to the negative 1 power. When we raise a number to a negative power, we simply take 1 over the number to the positive power. So 10 to the negative 1 is 1 over 10 to the 1 power. 10 to the negative 2 is 1 over 10 to the 2 power. 10 to the negative 3 is 1 over 10 to the 3 power. So a number like 257.5 A number like 257.5 is 2 times 100, 5 times 10, 7 times 1, and 5 times 0.1, because 0.1 is 1 over 10. 257.56 is all of that, but this last one is 10 raised to the negative 2 power. So positional notation is what we're using when we use decimal points as well. That's actually the key to understanding floating point representations in a computer. Not base 10, but still positional notation using decimals. So, positional notation. Positional notation is not unique to base 10. It's not distinct to base 10. If we lived in cartoon land, where you'll notice most cartoon characters have 4 fingers. They have a thumb and 3 fingers. Okay? If we let them evolve their own if cartoons could evolve their own counting system, they would probably have a counting system based on 8, because they have 8 fingers instead of 10. So, does that mean they can't use positional notation? No. It means the base, instead of 10, is 8. That's all that means. All that means. So a number like 257, if we were looking at base 8, we'd say, well, it's some quantity of 8 to the 0 power, which again is still just 1. There's nothing magical about 10 to the 0 power. And then we have 8 to the first power, which is our 8's digit. So instead of a 1's digit and a 10's digit and a 100's digit, if we were talking about base 8, we have a 1 digit, a 1's digit, an 8's digit. What would be the next one? What's 8 to the second power? 64. We'd have a 64's digit. And so on. There's no particular limitation on other bases. So the number 257 in that would be represented as 3 times 64. That's 192. Now I have to do some math here. 8, 58, 60. Oh, nope, that'd be 4. Sorry, 4. 401. So that's 4 times 64 is 256. 0 times 8 is 0. 1 times 1 is 1. 257 right there. So that's the base 8 representation of the number that I call 257. I only call it 257 because I have a base 10 cultural and evolutionary background. And there are many cultures around the world that use different number bases than base 10 in the past. There were cultures that used things on 12s, on 60s, on 30s, but kind of as a shared thing, we kind of converged to this base 10 representation. Large part originating with, we see a base, kind of a base 10, but not positional notation in Roman numerals. But then we see positional notation coming out of India and the Islamic world, and coming into Europe from there. But positional notation can be used with any number base. And that's all we need to do to understand how an alternative representation works is, well, we're used to one where this digit is the 1's digit, then the 10's digit, then the 100's digit. That's just because that's 10 to the 0 power, 10 to the 1 power, 10 to the 2. Down here, if we're in base 8, 8 to the 0 power, 8 to the 1 power, 8 to the 2 power. Questions?
Hey Nick.
Yeah.
Yeah, I understand the base power from 10 to 8 and all. Can you please go over how you converted 257 to 401? Can you do that again?
No, because that's what we're going to do next. I did that one in my brain, but we're going to learn how to do that.
Okay, great.
So there's really two things we want to be able to do. We want to go from kind of what we consider our native representation, because it's part of all of our cultural background. So a base 10 representation to any other number base. That one's going to follow this afternoon. First, we're going to say, well, understanding positional notation, could I take a base 2 representation? And then could I take that and convert that into an int? Now, an int is still a base 2 internally. But Java and most programming languages in their standard libraries, when we print out an int, they do the nice thing of representing that as base 10. But there's nothing magical about base 10, and internally it's stored as base 2. But if I have a string representation in base 2, so if I have a series of zeros and ones, because that's base 2. Okay. Notice that in base 10, we don't have a 10 digit. That's a 1 and a 0. We go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we start again. Same thing in base 8, 0, 1, 2, 3, 4, 5, 6, 7, and we start again. In base 2, 0, 1, And we start again. There are no 2 digits in base 2. There's not a digit for 2. We would represent that as 1, 0. We carry the 1. So we're going to go from a base 2 representation as a string, into and convert that into an int. That's going to be our job for our next task. So what I'm going to do is I'm going to start talking about that in terms of positional notation. And then I'm going to have you go into breakout rooms and see what you can come out in terms of some kind of pseudocode, however formal or not. Be as unambiguous as you can, but some kind of pseudocode that will do that task for us. So let's take an example. Let's take an example like this. I'm going to write this as, for various reasons, 257 is not the one I want to use. I'm going to do something else. I'm going to say 1, 0, 1, 1, 0, 1, 0, 1. So that's an 8-digit base 2 number. And I've written it that way deliberately. So again, we can look at positional notation. So if this is base 2, then what is this rightmost column? What position is this? So we talked about here that this is the ones column, and this is the tens column, and this is the hundreds column there. This is the ones column, the eights column, or the eights digit, whichever you want to call it, and the 64. So what would be the rightmost one here? That would be the 1. What about the next one to the left? That would be the 2. What about the next one to the left of that? That would be 4. The next one to the left of that, 8, and so on. Okay? And of course, that is all because 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. 2 to the sixth power is 64. And 2 to the seventh power. There's no magic in positional notation. It is absolutely predictable. There's no mystery about it at all. That's one of my main jobs here today, is to dispel the idea that there's some kind of thing that's just beyond comprehension. Most of us were exposed to alternative number bases very briefly in maybe as early as middle school, maybe high school, maybe college. But if we didn't study math or computer science, we said, boy, I'm glad I'm not doing that, because that was baffling to me. Because it's taught very horribly. It's not really taught as a coordinated thing in conjunction with understanding what we've been doing for years in when we manipulate numbers. We've been using positional notation, and so it's absolutely forgivable if this is some deep forbidden blocked memory in your past. It's like, God, I'm so glad I never had to think about that again. Well, guess what? Time's up. You got to think about it now. So there's no mystery to it at all. All right. Anybody? So now let's go ahead and figure out what this is. So this is going to be, and I'm actually going to go right to left right now for this. So this will be, I'll write this as a formula. 1 times 1 plus 0 times 2 plus, so I'm going right to left here, plus 1 times 4 plus 1 times 8. Let me try to make these a little more readable. I would normally put spaces on everything, but I want to group them together a little bit. 1 times 8 plus 0 times 16 plus 1 times 32 plus 0 times 64 plus 1 times 128, 173. Any questions about how I produced that number or how I arranged this up here? Great. So think about the tools you have available to you. And again, don't think about Java code. Don't think about Java code just yet. I'm going to put you in breakout rooms, but I really don't want to think about Java code. I want to think about pseudocode. I want to think about what are the steps we're going to follow. Remember that if you've got a string of characters, don't try to treat this as a number. This is a string of characters. So assume that your input is a string of characters, all of which are the digits 0 or 1, or each of which is the digit 0 or 1. Now, assume, just like we can do in any programming language, that you can iterate in some fashion over that string of characters, over that sequence of characters. You don't have to worry about exactly how that code works. Just write it so it's clear in your pseudocode. So you're going to iterate over those characters in some fashion and perform some kind of multiplication to iterate over these characters. And then you're going to, after you do each of the necessary multiplications, you're going to add them together. And you could probably add them together progressively. You don't have to get a bunch of numbers and then add them all together. You can say, well, I'm going to start with this one, or I'm going to start with this one, or whatever it is I'm going to do. I'm going to do the multiplication and put that into my running sum. And then I'm going to keep updating that running sum as I go along. That's one way of looking at this. There are many ways. There's no interesting problem that has only one possible solution approach. So we're going to do breakout rooms. We're going to do that for the next let's say 30 minutes. 30 minutes. And I'd like to get pseudocode from that. So when we do the breakout rooms, please follow the usual practice of identifying who's going to share a screen, who's going to keep the notes, who's going to kind of drive the conversation, and whoever is keeping the notes, that should probably be the person that speaks for it afterwards when we come back. So we're going to do this for 30 minutes. We're going to take a break, 10-minute break after that, and then we'll come back out and hopefully we'll get some code before lunchtime. Any questions? All right. I'm going to move some people around between rooms because it does a pretty crap job of shuffling. So I'd like to do a little bit better job of shuffling this. Okay, there we're talking. Keep doing that. Okay, well, we'll take it from there. And there. Well, that's right, we have 22 people here, I believe. Maybe 21. I think we might have one person out this week. All right. Okay. Please feel free to send out the bat signal if you get stuck. Again, don't worry about Java syntax or Python syntax or JavaScript syntax. I want unambiguous pseudocode as much as possible. You know, if you're a little out of practice for that, that's fine. But basically write the steps in a clear, easily understandable way. Use step numbers, use indentation, whatever it is. You don't have to use the notes pod because the notes pod's not really great at formatting, but if you use the notes pod, that's great. If you don't, then I suggest using some online tool that you can present, or even if just a Word on your own machine, just be ready to present that. All right, let's get to work.
Hey guys.
Hey, how's it going?
Hello.
How you guys doing?
Oh, all right.
I'm doing all right. How are you guys doing?
I'm doing well. I'm just trying to. I was thinking about already how to solve this and stuff. How do you guys feel about
Okay, I'm
algorithms?
super nervous about it. It's a lot.
Yeah. Yeah. Kind of questioning, everything I've done to get here.
It's like a cool thing, but I'm like, okay. Now once we started doing this, and I'm like, it seems like okay, now we have to make this pseudocode, and I'm like, I don't even really understand how he just converted these damn numbers, but okay.
So it's only the pseudocode we need to do.
Yes.
Yeah.
Well, basically, like,
Yeah, I thought maybe I missed the problem or the prompt. I know we're
I
working.
think it's just like how to do these conversions that he was showing, like how would you make an algorithm, but just using like pseudocode. So what would be the
Okay.
steps that we would have to take to do the
Got it.
conversions?
Got it. Okay. I mean, it seems a little bit like a for loop, right? He kept adding one and going through it.
So I'm just gonna write this stuff
Yeah.
down, and then we'll kind of like clean it up.
Yeah. Okay. Right when he
Because I think
showed.
there's something to do with dividing by 2.